Welcome to our tutorial on data analysis with BigQuery. My name is your name, and today we'll dive deep into how you can harness the power of Google Cloud's BigQuery for efficient and scalable data analysis. BigQuery is a fully managed, serverless data warehouse that allows you to perform fast SQL queries on large data sets. Whether you're a data analyst, data scientist, or a developer looking to analyze data seamlessly, BigQuery will enable you to do it with ease. In this tutorial, we'll cover the following key areas. First, we'll set up our BigQuery environment. Next, we'll load some sample data sets. After that, we'll perform some basic queries. Then, we'll look into aggregations and analytical functions. Finally, we'll finish with best practices for efficient querying and a summary of what we learned. All right, let's start by setting up our BigQuery environment. You'll need a Google Cloud account if you haven't already created one. You can sign up for a free trial to get started. Once you're logged in to the Google Cloud Console, navigate to the BigQuery section. If it's your first time here, you might have to enable the BigQuery API. Just follow the on-screen instructions to do that. Now that our environment is set up, let's load some sample datasets. Google provides a public dataset that we can use for our analysis, BigQuery samples. To load the dataset, click on Add Data on the left pane and then select Explore Public Datasets. In the Public Datasets section, search for the dataset named BigQuery Public Data, Samples.Shakespeare. This dataset contains data about the works of William Shakespeare and will be great for our analysis. Click on it to explore. Now that you've found the dataset, let's run our first query. Clicking on the Query Table button will open an editor for us to write our SQL queries. Let's start with a simple query to select a few rows from the dataset. Type the following SQL query into the editor. Once you enter the query, click on the Run button. This will execute the SQL statement and show you the results below. As you can see, the dataset consists of multiple columns, including word, count, and corpus. This provides a great foundation for our data analysis. Now that you have executed your first query, let's perform more complex queries, starting with aggregations. We might want to know the total number of times each word was used across all of Shakespeare's works. This query groups all the entries by word and sums up their corresponding count values, giving us a clear picture of the most frequently used words in the dataset. Go ahead and run the query. Fantastic! Now you can analyze the output and see which words dominate Shakespeare's vocabulary. Remember, queries can be refined or expanded upon based on your analysis requirements. Next, let's explore how we can leverage analytical functions. Let's say we want to know the average word count per play in Shakespeare's dataset. This is where window functions come in handy. In this query, we first created a derived table to sum up the word count by corpus. We then calculated the average word count for each corpus. This step-by-step breakdown makes complex aggregation tasks manageable. Let's run this query and see what the average word count per play looks like. Look at that! Now we have insights into how much each play varies in its length, which could reflect the complexity or style of Shakespeare's writing in different works. Now that we've explored some basic queries and aggregations, let's discuss best practices for querying in BigQuery. First off, always ensure to limit the data you're querying to minimize costs. Using the where clause effectively allows you to filter data smartly. Secondly, avoid select asterisk in production queries. Instead, specify only the columns you need, as this reduces the data scanned and therefore your cost. Another useful trick is to use table partitioning and clustering. By partitioning large data sets based on date or another dimension, you can significantly enhance query performance and reduce costs. Finally, remember to take advantage of BigQuery's caching. The results of your previous query are cached for 24 hours, enabling you to run the same query again without incurring additional costs. This is a subtle yet powerful way to optimize your workflow. As we wrap up our tutorial today, let's summarize what we have learned. We set up our BigQuery environment, loaded datasets, executed basic and complex queries, and explored best practices to enhance our query efficiency. I encourage you to explore further using different datasets available in BigQuery. Practice the SQL queries discussed in this video and see how modifying them impacts your results. Thank you for watching this tutorial on data analysis with BigQuery. Don't forget to like, share, and subscribe for more tutorials on data analysis and programming. Until next time, happy querying!